What would happen if you fell into a black hole, the cosmic phenomenon that pushes the boundaries of our understanding of space and time? Well, first, what is a black hole? To comprehend black holes, we must first grasp the profound connection between space and time. Space isn't static, and time doesn't tick uniformly everywhere. They are relative. Matter, like stars and planets, bend the fabric of space-time, creating gravity. Think of space-time as a trampoline where the universe sits. Black holes, however, are like a hole in the trampoline because they have so much mass, breaking the trampoline in the same way as black holes break the laws of physics. Most black holes form when massive stars reach the end of their life cycle. In their final moments, they implode at nearly a quarter of the speed of light, packing an immense amount of mass into a very tiny space, breaking the trampoline. Now, the border of the black hole is called the event horizon, an invisible one-way border encircling it. Cross this threshold and there is no return. It's like a cosmic no-go zone where the rules of the universe, as we know them, cease to apply. But don't expect to see a black hole if you look directly at one. The event horizon obscures our view, trapping everything within its grasp, even light. However, we can still observe them by their effect of nearby matter. The closer you get to a black hole, the stranger things become. Gravity near black holes is so intense, time slows down, creating a surreal, one-way time travel experience for those daring enough to venture close. But getting too close to a black hole is dangerous. You would undergo a gruesome process called spaghettification. This is where the tidal forces are so extreme that you'd be stretched until you become a thin stream of hot plasma before being devoured entirely. If somehow you find yourself inside the event horizon, the rules of space and time warp dramatically. Every movement forwards leads towards the singularity, which is the heart of the black hole. Now, the singularity is a point of infinite density where all matter that crosses the event horizon is crushed into an infinitely small size. It's as though the universe forgets everything that enters the black hole. Black holes are described by three main properties: their mass, spin, and electric charge. Everything else vanishes into the singularity. Most black holes rotate due to the conservation of angular momentum. This momentum originally comes from when the star that formed the black hole was spinning extremely fast. This rotation creates the ergosphere, a region where staying still is literally impossible, and space itself is dragged along. Over incomprehensible timescales, black holes can gradually lose mass through Hawking radiation, a quantum effect near the event horizon. As they shrink, the radiation intensifies until they eventually evaporate in a burst of energy. But the lifetimes of black holes are staggering, with even the small ones lasting eons. In a universe aging and changing around them, black holes remain constants, quietly defining our attempts to fully understand them. Will we ever unlock the secrets of black holes? At present, we can only see their exteriors, and the mysteries within remain elusive. But that's what drives us to keep exploring, to seek the answers to the questions that challenge our understanding of the cosmos. On the massive trampoline of the universe, black holes continue to play their role, reminding us that there's always more mysteries to solve, more discoveries to make, and more wonders to contemplate.